Hello, Professor. Our group has two members, Niancheng Xu and Nubu Hammock. Our group project is about California housing. The data pertains to the house found in each California district and some summary stats about them based on the 1990 census data, and the data results comes from the StatLib repository. In the first semester, our group already done a project about the American housing problem, but that project is conducted from a micro perspective, since the factors are regions, water and electric situation, and some more related variables. So this time we want to have a deeper insight of housing problem. By the way, the target variable of our project is median house value, which would finally tell us each factor has what kind of effect on the final value of a house. First, I display the schema of the dataset, and we can see that all the variables are in float type, although some of them are actually integers, but being float can be more convenient to do the following analysis. Here is the data dictionary. Housing median age is the median age of a house within a block. A lower number is a newer building. Median income means median income for households within a block of houses. Median house value means the median house value for households within a block, which is our dependent variable. Then we go to see some basic plots to have a general view of the data. First, we see the relationship between population and house value. This distribution is not looking nice, and we can't say that block with more population can have a higher house value. Second, this is the relationship between median income and house value. This picture looks much prettier and clearer than the first one. Here we can see that besides some outliers in the left part, the general trend is that blocks with higher income can have a higher house value. This is easy to understand. People who are richer can afford a better house. Then we see the median age. The trend is almost stable among all the different ages. In other words, the median age doesn't have much effect on the house value. This plot we use the longitude and latitude to show the relationship between house value and geographical location. It's clear that houses which are closer to the ocean have a higher median house value. Also, the relationship between total number of bedrooms and house values is also clear, which has a regular pattern. Last one is the total number of rooms, not only bedrooms. This is interesting since it doesn't have a similar distribution as the previous one. The median house value reaches the top when the number of rooms is about 2 or 3,000. After that number, more rooms, less value. And these are some supplements of the plots. Finally, we went into the next step, which is the preparation of the dataset. The first plot shows that the basic information of the data, and luckily there's no missing value in our samples. All the variables have 20,640 samples. Later, when we display the histogram of our dependent variable, we found that the distribution is in a shape which is like a log function. So we use log to normalize the target variable. Here we can see it almost changes into a normal distribution. By the way, the value of dependent variable becomes much more smaller than the original one, which is convenient for us to do the analysis later. The last step we did was to add some meaningful new columns. For example, the rooms per household column is the number of rooms of each household. This is the summary statistics of the dataset. The distribution of three variables in the center are similar, and that of median age and the median income are totally the opposite. Till now, we already knew a lot about the data, so we can start to fit different models to see the accuracy and predictions. The first model must be linear regression since our variables are all numerical. We set a features column using 7 meaningful variables, and then split the data set into training and testing data to fit the model. Here we check the coefficients first. The number of bedrooms per room has a stronger positive effect on the house value than others. The mean squared error is about 0.16, which is not bad but should be smaller if possible. And the R squared is about 0.5, which means only a half of the samples can be explained by the model. For the test set, the results are similar. So honestly, linear regression doesn't have an ideal performance here. Then we did the clustering. We set k equals to 3, and the centers are shown in the result. The silhouette value is about 0.81, which is close to 1, so the different clusters are not similar to each other. This is a good result we want. Finally, we conducted a gradient-boosted tree. From the result of feature importance, we can see that the median income is the most important factor here. The root mean squared error is about 0.35, which is smaller than the one of linear regression. We can get many useful information after the analysis. Here are some of the conclusions. First, linear regression doesn't play an ideal performance, and gradient-boosted tree can be a better choice. Second, the number of bedrooms per room has a stronger positive effect on the house value. Third, block with higher income can have a higher house value. Also, median income is the most important factor. And fourth, median age doesn't have much effect on the house value. Of course, there are also some other more conclusions. And we can get many business suggestions here. And the first one, we can buy the house along the ocean side whose value can increase a lot when sold out. Second, don't force the age of house to be old or young since the value doesn't rely on it. Also, house with more bedrooms can be more valuable. There can be other more suggestions here, but I just don't mention them here. That's all. Thank you for listening.